Good morning to all. So today's class is all about I2C communication. We are going to learn about the next protocol, I2C. So I2C we can see, or IAC or I2C, both are same. All and all. Now these are the various terms of using of I2C. It is called as a inter-integrated circuit. It's a two-wire bidirectional interface. So only it needs of two wires and bidirection. In both the way I can able to transmit the data. Similarly for SPI, and we can have more than one master and more than one peripheral devices which are called as a slave devices. So what are the slaves I can able to connect it is EP ROM, electrical erasable ROM, ADC, RAM, LCD, DAC. These are some of the external devices. In some case, either we can connect sensors also by using this I2C. So it needs two wires. As already in the previous slide we have given us two wire communication. We need SDA and SCL line. SDA for serial data and SCL for serial clock. So with the help of the one data line, I can able to transmit the data from one master to the slave, and clock signal should be keep on sending by using SCL. So first let me assume that there was one master and one slave. I want to transmit 8 bits of data. So how to do that is, after sending 8 bits of data using SDA line, the acknowledgement bit is to be driven by the receiver. It means that all the 8 bits have been received by the receiver. In order to intimate that to the user end, a low acknowledgement bit is also given at the end. So I show the pattern. So first 8-bit data, in that 8-bit data the MSB is first sent out, and the last, after the last LSB have been given, the receiver should acknowledge with the bit 0, that is low bit is driven by the receiver. So after successful reception of 8 bits of data, the receiver is the person who will send the acknowledgement bit. So on receiving the acknowledgement bit, the master will come to know that all the 8 bits have been transmitted. So this is how the transmission will look like. And then comes at the addressing protocol. Suppose many slaves are there. Each slave has given a set of address. Either it can be of 7-bit address or it can be of 10-bit address. So first, in order to transmit the actual data, first I need to find out to which slave I am going to transmit the data by using this address, and then only I can able to transmit the data. So I'll show a diagram where it will look like this one. It's very easy only. So first, a start condition, which is nothing but a high pulse I am going to give, and then the master will send a 7-bit of slave peripheral address, 7-bit, or it can, in some time it can be a 10-bit address. The address will be given, and the last bit will be a read or write bar. If I am going to read, this bit should be high. If I am going to write, this bit should be low. It depends upon to that particular slave what I am going to do, whether I am reading the data or whether I am writing the data. Then it is followed by the acknowledgement. Who will give the acknowledgement? The slave will provide the acknowledgement, and then followed by the internal address in the slave peripheral. This 7-bit is a physical address, and in the RAM, in the memory, to which address I am going to write the data, that internal address to be given from the master. For that, the acknowledgement is given by the slave, and then the actual data. So data to be written in the address, then the acknowledgement, then the next address, the data and the acknowledgement. Likewise, how much data I am having, the master is having, all the data will be transmitted to the slave address in the particular internal memory address, and for each 8-bit of data, the acknowledgement is provided by the slave. Once all the data has been written to the slave, the last condition is a stop condition. So this is how I2C communication will work. Thank you.